About independent and dependent events. So first, the definitions of those two terms. Two events are independent events if the occurrence of one event does not affect the occurrence of the other event. And we're going to get some examples of this to make it a bit more clear. Dependent, two events are dependent events if the occurrence of one event does affect the occurrence of the other event. So one tip that I have for you throughout all the problems you'll work on is that if there is replacement, like if you're choosing things multiple times and there is replacement, events are usually independent. That is, what happens on one choice does not affect what happens on the other. If there is not replacement, like if you take something out and you keep it out and then you choose again, events are usually dependent, because usually the fact that you took it out changes whether the affects how the other event goes. Now, first, let's just think about distinguishing between independent and dependent. So here's a situation we're going to think about. Is it independent or dependent? A box of granola bars contains an assortment of flavors. You randomly choose a granola bar and eat it. Then you randomly choose another bar. So the first event, you choose a coconut almond bar first. Second event, you choose a cranberry almond bar second. Now, you should think back to the tip I gave, which is that if there is replacement, then it would usually be independent, and if there is not replacement, it would usually be dependent, because what you choose on the first one determines what's available on the second one. Here it says that the first one you choose, it says you choose a granola bar and eat it. You are not going to replace that eaten granola bar, so that means it's not available for the second choice. So the first event does affect how the second event goes, because depending on what type of bar you choose, that determines what's available for the next choice. So these are dependent for that reason. And it fits the tip I gave, which is that if there is no replacement, it's usually dependent. Now, independent or dependent, again, so we're deciding for this new situation. It says you roll a six-sided die and flip a coin. Event A is you get a 4 when rolling the die. Event B, you get tails when flipping the coin. Now, admittedly, this tip I gave about no replacement and replacement doesn't really apply here, but what now you're thinking about is, does what happens on the first event, in the first event, affect how the other one will go? So you roll a die and you get a 4. Is that going to change whether you get a heads or tails when you flip a coin? No. Flipping a coin is always, well, flipping a fair coin is always 50-50. There are always two possibilities, two equally likely possibilities, and what you do before that isn't going to affect it. So first event does not affect the second one or affect the outcome of the second, and so these are independent events. Now, here's a third one where we're going to decide if it's independent or dependent. Your MP3 player contains hip-hop and rock songs. You randomly choose a song, then you randomly choose another song without repeating song choices. So this relates to replacement again. If you choose a song and then the next one you choose will not repeat, that means that first song was basically taken out of the possible choices, and that does affect what's available to choose for the second one. So this is again going to be dependent because basically because it's without replacement. Now here's another situation. There are 22 novels of various genres on a shelf. You randomly choose a novel and put it back, then you randomly choose another novel. So you put the first one back, meaning when you choose the second time, you have the same set of choices. Nothing is different the second time around because you put the first one back. The first choice should not affect how the second one goes, so these are independent events. Okay, so how do you calculate the probability of independent events? There's this rule here, and I'll say these things out loud so you know what they mean. If you have two events A and B, the probability that both A and B occur, so that's this term, probability that A and B occur, is equal to just the probability that A occurs multiplied by the probability that B occurs. So you just multiply the individual probabilities when you have independent events, and we're going to see an example of this next. So, you play a game that involves spinning the money wheel shown. You spin the wheel twice. Find the probability that you get more than $500 on your first spin and then go bankrupt on your second spin. It says see example 3. That's just the examples in the book. So you could look at example 3 in the book if you want a clue on how to do this one. But let's define the events or review what the events are. Event A is that you get more than $500 on your first spin. Event B is that you go bankrupt on the second spin. And they're asking what's the probability that both A and B happen. So we're going to figure out, okay, what's the probability since these, okay, first, these are independent. The reason is the set of choices that are available, that set of choices is the same on the first and the second spin. It's not like you take out an option. If you spin something on the first spin, you could still spin that same thing on the second spin. So this is basically with replacement. I mean, it sounds weird to say that, but because your options are the same on both spins. So these are independent, which is why I'm using the rule for independent events. Just multiply the individual probabilities. So what is the probability that we get more than $500 on our first spin? So we're going to spin it. We're going to assume all these possibilities are equally likely. So basically we're going to think how many do we get more than $500 and then how many possibilities are there total? Well, total, we would just count up all these options. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 possibilities total. How many of these would result in you winning over 500? So not bankrupt, this $5,000 one would count. So 1. Here's another option above $500, so 2. Here's another option above $500, so 3. Here's another option above $500, so that's 4. Another option above $500, so that's 5. Another option over $500, so that's 6. Another option over $500, so that's 7. And then another option over $500, so that's 8. So the probability of getting more than 500 on your first spin is 8 out of 24. That's where this comes from. And then the probability that you go bankrupt is 2 out of 24. Because there are 2 bankrupt options out of the 24. So we just multiply these together. If you multiply fractions, you can multiply across the top and the bottom. So 8 times 2 is 16. 24 times 24 is 576. And this, when you do it on your calculator, is about 0.028 So that's about 2.8%. That's the probability that both A and B will occur. That you will get more than $500 in your first spin and go bankrupt on your second spin. Okay. How about dependent events? How are those different? So there's still multiplying going on, but if you have two dependent events, the probability of A and B is equal to the probability of A times the probability of B given A. What that second thing means is assume A has already happened, then what's the probability of B? So that's what probability of B given A means. Let's see an example of that. A drawer contains 12 white socks and 8 black socks. You randomly choose one sock, and do not replace it. Then you randomly choose another sock. Find the probability that both events A and B will occur. So the first sock is white, is event A, and then event B is that the second sock is white. Now, why is this dependent? Well, they said that you are not replacing the first sock. So this is without replacement. Your options are not the same on the second round. What you get on the first determines what's available on the second. So these are dependent, and we're going to use the formula for dependent. Those are the events, again, just to review them. And then we're using this formula because it's dependent events. We have to think about the probability of A times the probability of B given A. And here's the reasoning here. So what is the probability of A that the first sock is white? Well, initially there are 20 socks total because 12 plus 8 is 20. And 12 of them are white, so 12 out of those 20 possibilities would result in us getting the first sock as white. Okay, now, this probability of B given A. So that means, what is the probability that the second sock is white, assuming that the first sock was white? So if we are assuming the first sock was white, that means there's one less sock total, so 19 instead of 20 total, but it also means that now there are only 11 white socks instead of 12 because the first one that we picked was white. One of the white ones is now gone. So that's what we mean by probability of B given A. We're assuming that in the first one we picked a white one. Now here's the probability of choosing a white one for the second pick. We multiply these together, and it's about 0.347, so about 34.7% is the probability that we'll pick a white sock the first time and then also pick a white sock the second time. I hope this video helps distinguish dependent and independent events. Please email me if you have questions, and good luck with this. I do imagine we'll have one more unit or lesson this week other than this one. Okay, thanks everybody. Bye.